You've seen this amplifier before. This is the Pioneer A400. It's an amplifier I use at home. I've got a couple of these, and my landlord's actually borrowing my better one. My original Pioneer A400 I bought second hand back in, I suppose it's the early 90s, and it worked very well for many years, but it finally packed up. All the connectors on the back of the speaker terminals all sort of crumbled away. So I bought this one on eBay about 2 years ago, and it came not in a non-working condition, powered up, totally dead. And I don't know if you remember, if anyone remembers seeing this video, but there's a crack in the circuit board down here, just behind this screw where this junction point is. Let me have a look. You can see just round there, it is round by those connectors there, just behind that orange lead. There's a crack there. The board was cracked in half, and it had lost the 0-volt connection. So you switched it on, and nothing happened. I repaired that, and I seem to remember, I need to go back and check the video, that was all that was wrong with it. So I've been using it, and it's been behaving perfectly well for the first year or so, and then it suddenly developed this fault where it would like start buzzing really loudly more out of one channel than the other, and it will activate the protection circuitry. And then that would usually only last a couple of seconds, and it would clear again, and the speakers would re-release. But if you plugged in the headphone socket, which actually mutes the speakers, released, you could hear there was a click on the speakers, which indicates there's a DC offset present on the outputs, which is not ideal. I mean, it's okay if it's a small DC offset, but ideally there should be none. And these usually idle around about 335 millivolts or something like that on the offset, and that's all controlled by biasing transistors and sort of self-servoing themselves, constantly trying to keep the center potential of the output of the transistors at 0 volts, so the output stage is always kept balanced. The transistors kept on the same point, so they share properly, so they balance properly. Anyway, this problem has got worse and worse, and I came home, I think it was last week, switched the amplifier on, usually expecting it to do a few buzzes, turn off and reset itself, and it never released the protection relay. So I opened it up and had a look inside just at home, had nothing to test anything with, apart from a DVM, and found that it looked like there was a minus, the minus supply from the output capacitors was missing on one of the whole thing was missing a minus volt supply. So I'm thinking, oh, maybe there's still a crack on the power supply. So I've opened it all up and had a look round, and it all looked absolutely fine, and powered it back up in the workshop, and it worked briefly. But in the meantime, I found that the amplifier had been connected to my sound card on my PC, which is an expensive Sound Blaster sound card, and it looks like it's blown the sound card up. The audio is very badly distorted, and I've tried changing the op amps, that hasn't fixed that. So it looks like it's actually, maybe, I mean, it might be just coincidence, but it looks like it's put DC on the input and blown everything up. So I thought I'll get it down in the workshop and have a look, see what's going on. Did also notice that playing it at high volume levels, it sounded, it wasn't a horrible distortion, but it sounded like it was all sort of, almost like it was all muddled up. The sound didn't sound right. And a couple of times I was playing at moderately high levels, and again it activated protection relay. So I thought, well, I'm going to have to look at this amplifier. And this is what I found. I'm feeding from the HP 8903. I'm feeding a 1 kHz tone into the amplifier, and if I drive it with the, if you see on the scope up here, if I increase the drive slowly, you see it looks absolutely fine. And then we get to a point, there's a bit of a noisy pop there, just jumping around, and you watch what happens now. And I don't know if you can see that, but serious asymmetrical clipping. So you think, well, okay, one of the drivers isn't probably working on this stage. So I come back and check the other stage for comparison. So we'll look at the other stage. Now basically these are the emitter follow resistors I'm looking on here. So you've got a 0.33 ohm here on this one, and a 0.33 ohm here, and that's your center point. That goes off to the output inductor here, which goes to your outputs of your speakers. So let's look at the other channel and see what that looks like. So we'll wind it up. Exactly the same. So okay, you think, well, that's a bit unlikely in the stereo amplifier. So what I'm thinking now is there's only one thing common to a stereo amplifier, and that will be any power supply section. So I think, so well, is it maybe a dried up filter capacitor? So let's have a look at the supplies to the amplifier itself. Now the supplies are just come in here on these orange and green wires. Let's just have a look at that. So I'm going to AC couple the scope and connect that to there, and increase our volts per division, or should I say decrease our volts per division, so we can see any ripple on the supply. So we'll go to half a volt per division and start winding the amplifier up. Now you expect some ripple breakthrough. So running on single channel drive running into 8 ohms at the moment. 4 ohms at the moment. I don't know if you heard that. The relay just activated its protection circuitry. Do it again. Let's just look at the wind it up again. There's no power supply disturbance there. Again, relay's activated. We'll have a look at the negative going side. Or that's the positive going side, I think. It seems to be taking more current out of that supply, and that protection relay only activates when I've turned the volume down. And what happens is, if you look at the output of the waveform on the output of the amplifier again, you'll find that when you turn the volume down, there's a big swing. Okay, so we need to go DC coupled. So I'm going to have fairly low volts per division, so we're going to get we go off the scale pretty quickly. Let's put it on the right channel. Okay, so we're going to clip and turn the volume down. You see that swing, that DC swing? Let's increase that on times 10 actually, so that's 5 volts per division. And now on half a volt per division. Do it again, turn the volume right up, turn the volume down, and there's a DC swing as it all settles down. So there's something seriously wrong with this amplifier, and it would initially suggest that it's a power supply problem. The problem with modern high performance amplifiers, it's very hard to find the fault where the distortion's occurring, because what the amplifier uses is a lot of negative feedback. So output from the audio output from the output stage is fed back into the preamplifier. This reduces distortion and can improve stability of the amplifier, but also makes it impossible to actually diagnose where the fault is. Now, short of going through and taking out each transistor and testing it, I think what I might try and do, and I don't know if it's actually physically possible to do this, is to remove the negative feedback link and then run the amplifier in the low power mode, or certainly to the point where it starts to distort, and see if we can trace through and find where it is. Now, it would initially suggest to me, and I don't know if anyone's got any other ideas on these amplifiers, I would say it's one of these current drive transistors. So we've got basically an amplifier comprises of a voltage gaining amplifier at the beginning to get the voltage up, and then the two final drivers, which are this transistor here and that transistor there, is the primary driver, and then there's a secondary, the main output transistors here do all the work and produce the high current capability. So basically I'm looking for maybe a driver that's faulty, or maybe even there's a servoing problem somewhere. I've checked the quiescent current, and that's adjusted by these pots here, that's fine. But I still in my mind think that there's a problem with the power supply. I've looked at the power supply with the voltmeter, and the voltage levels drop at the same level, so it's not like one side of the power supply is dropping way badly and causing it to clip prematurely on one channel. There's something very odd with this amplifier, and it could be something like a bad ground point that's, you know, not there. I need to check around the power supply again, but that's where we are with this. This amplifier is going to have to be fixed, because this is sort of the one I listen to in my bedroom, and I want this one back and working. I have, as I say, I have got another one in spares actually that's got all the connectors that are broken off. I could probably make 1 out of 2, or 2 out of 1 should I say. But anyway, I'm going to go through that and start doing some checks. I'm not going to be any videos in the coming week because I'm off on holiday to Cornwall. I've got the parts for the Marconi 2305. The chip that I think might be the problem has turned up. So, and also I've got the chip for the display driver, so that'll be on its way. Anyway, thanks for watching, and see you in a week.